Hi, good day. Welcome back to our class. Today, we're going to continue discussing on the kinds of matter and their properties, particularly in the classification of matter wherein we have already started discussing on the pure substance and the mixture. Then let's go down to the mixture part. In the mixtures, we have classified them as two, homogeneous and heterogeneous mixture. Today, let us discuss about how to separate mixtures. There are methods in separating mixture. One is chromatography. In chromatography, the mixture is allowed to pass through a medium in which the components will be separated as they move at different rates. There are types of chromatography. One is the TLC or the thin layer chromatography, and this is applicable to separating a mixture which are colored, such as the pigments. Another is the HPLC, or which is known as the high performance liquid chromatographic column. Another method of separating a mixture is by distillation. We know that distillation is a process in which it involves two processes like evaporation and condensation. In distillation, the mixture is allowed to evaporate and condense. Now, those components which have low boiling points will be evaporated first. So they come out as the first condensate, known as the distillate. Therefore, in distillation, the separation of the components of a mixture is based on the differences in their boiling points, because those components with low boiling points will be evaporated off and condensed first, so it will come out to be the first fraction of the distillate. I can cite you a good example for distillation, like when you are going to distill a liquid that contains alcohol, particularly the tuba. When you are going to distill the tuba, this tuba contains alcohol. You have to regulate the temperature not more than 80 degrees centigrade, because the ethyl alcohol which is contained in the tuba will boil at 78.5 degrees centigrade. And beyond that temperature, it's no longer the ethyl alcohol that will be collected as the first distillate, but there are other components of the tuba perhaps. Now, the remaining fraction after collecting the tuba, when it is boiled at 100 degrees centigrade, then you are sure that this contains already water, because water boils at 100 degrees centigrade. So you have already separated the ethyl alcohol from the other components such as the water through the differences in their boiling points. Another method of separating a mixture is by filtration. In filtration, we're going to separate a solid from a liquid using a porous material. In the laboratory, the porous medium that we use is the filter paper. So when you use the filter paper, of course, you're going to use this together with a funnel, and then you're going to pour the mixture of the solid and the liquid into it, allowing the filtrate to pass through the filter paper or the porous medium, thus separating the liquid from the solid. Another method of separating a mixture is by evaporation. In evaporation, This involves the heating of a homogeneous mixture where there is one or more soluble components in it. So, the liquid component will be evaporated off, leaving behind the solid component as a residue. Another method of separating a mixture is by decantation. In decantation, this is a separation of a solid from a liquid by carefully pouring slowly the supernatant after letting the solid settle down at the bottom of the container. Another method of separating a mixture, especially those which is a heterogeneous mixture, is by the use of a separatory funnel. Now, when you have a heterogeneous mixture, the components of this mixture may have different densities, so they are not mixed. This is what we call immiscible substances. The lighter component will float above the denser component. So using the separatory funnel, the denser component can be drawn out first and the lighter component will be separated last. Let's go to the properties of matter. There are two properties possessed by matter. One is the physical property, and two, we have the chemical property. For the physical properties of matter, these are the properties in which it can easily be measured or observed, such as the color, the texture, the odor, the mass, the volume, the density, the boiling point, and the melting point. The physical properties of matter is of two types. We have the extensive property and the intensive property. When we talk of extensive property, this depends on the amount of the material or the substance, like the mass or the weight and the volume. While the other one, which is intensive property, this does not depend on the amount of the material. This includes the color, the odor, the texture, the boiling point, the freezing point, the density at a specified temperature. So those are the types of physical properties of matter. Another property of matter is the chemical property. For the chemical properties of matter, this describe the characteristic of a substance to react, to form a new product, or the possibility of matter to undergo a chemical change. Examples of chemical properties are its flammability, the susceptibility to corrosion, its reactivity towards water and oxygen, its toxicity, and its pH. Now, those are the physical and the chemical properties of matter. Let's go to the physical and chemical changes that matter undergoes. For a physical change, this is only a change in matter in which the components of matter remains the same. That means, whatever is the component of the reacting material at the beginning is the same component of the reacting material at the end. Examples of a physical change is the change in state. What are some examples of a change in state? One is the melting. When a solid becomes a liquid, that is called melting. Or freezing. When a liquid turns into a solid, is freezing. Evaporation. When a liquid changes into a gas. Condensation. When a gas is converted into a liquid. Sublimation. When a solid is converted into a gas without passing the liquid state. There is also crystallization, in which a crystal is formed out of a supersaturated solution. Other examples of physical change are the separation of mixtures, making a solution, and physical deformation, such as cutting a paper, stretching a rubber, or bending a wire. Another change in which matter undergoes is the chemical change. In a chemical change, there are new components or substances which are formed after a reaction has taken place. Good examples of a chemical change are the burning of paper. When you are going to burn a paper, the component of the paper is a cellulose. The cellulose is a polymer of glucose. So if glucose has the formula C6H12O6, that is only a monomer of cellulose. So because cellulose is a polymer of glucose, so we can see here a series of glucose units. Now, when the paper is burned, this series of glucose units called cellulose will be only converted into carbon dioxide and water. So the new products formed are the substances carbon dioxide and water. You can no longer see the C6H12O6 series. Another example of a chemical change is the formation of water. Imagine water is a liquid. If you're going to look at the reactants, they are gases such as the hydrogen gas plus the oxygen gas, and these two, when they react, will form water. Water is a new substance which is composed already of the hydrogen and the oxygen. Another example of a chemical change is when you are going to burn a combustible material such as methane. Now, methane has a component CH4, or 1 atom of carbon and 4 atoms of hydrogen. When this will undergo combustion, this will react with oxygen in order to form carbon dioxide and water. So the component CH4 of methane is no longer found after it has reacted with oxygen because its final product is the carbon dioxide together with water. Another example of a chemical change is the rusting of the iron. When the iron reacts with oxygen, it will form ferric oxide. Now, in the process of reacting the iron with oxygen, of course, it has to pass through the lower oxidation state of iron first. That means, before the ferric oxide is formed, ferrous oxide is first formed. The reaction goes on until the higher oxidation state of iron is attained. So, the ferric oxide, which is commonly known as rust, is formed. Another example of a chemical change is the burning of the magnesium ribbon. When we are going to ignite or burn the magnesium ribbon, this will form a very bright light, leaving a white ash. So, when the magnesium reacts with oxygen, it forms magnesium oxide, that white ash that is left after the magnesium ribbon is burned. So those are the physical and the chemical changes which matter undergoes. For clarifications about our lessons today, just write your comment below. So that would be all for today. We have already done discussing the whole chapter about matter and its properties. So we're going to have a quiz next meeting about the chapter. This is your teacher, Professor Necitas Ruiz of Holy Name University.